In this video, I am going to teach you the two types of important problems. First problem, a line passing through the given point and parallel to given line. This is the one type of problem, and a line passing through the point and perpendicular to another line. So these two types are very important and frequently asked in many other examinations. So in today's video, I am focusing myself to tell you the method to find equation of line passing through the point parallel to given line, equation of the line passing through the point and perpendicular to another given line. First problem, find equation of a line passing through the point 1, 2 and parallel to the line. Solution. Whenever such problems are given, first of all, you draw a rough diagram. This is a required line and this line is passing through the point. The coordinates of point are 1, 2, call it point A. And it is parallel to the given line, that is 2x plus y plus 6 equals to 0. Whenever we want to find equation of a line in two dimensions, so the two important things are there. That is the slope of the line. Slope of the line usually denoted by m, and the point through which the line is passing. For example, here x1 and y1, and also y-intercept made by the line. Y-intercept made by the line usually denoted by c. So what is m? M is the slope of line and c equals to y-intercept. Y-intercept made by the line. And to find the equation of the line, we need to have slope of the line. Once you have the slope of the line, you can apply one point formula. What is the one point formula? Y minus y1 equals to m multiplied by x minus x1. This formula involving coordinates of the point A as well as the slope of the line. So this formula we usually use whenever we want to find the equation of the line if the coordinates of points are given and the slope of the line are given. This equation is also called one point slope form. Now here is parallel line. Equation of parallel line is given by ax plus by plus c equals to 0, and where a equals to 2 comparing with, so b equals to 1 and c equals to 6. So slope of this line m equals to, given by the formula, minus a upon b, where a value is 2, so minus 2, and b value equals to 1, therefore m equals to minus 2. And our line is parallel to this line. So slope of any two parallel lines are same, therefore m equals to, here is the m equals to minus 2. And we have the coordinates of point, we can call it as a x1 and y1. Now we'll apply one point slope form. Y minus y1. Y1 is nothing but 2. x1, y1 are the coordinates of given point. So x1 is 1 and y1 is 2. So putting these values here, so y minus y1, y will remain the same. Y will not be changing. So here y minus y1, that is y minus 2, equals to m is minus 2, and x minus x1, that is x1 value is 1. So putting 1 here. Now simplifying, opening all the brackets, y minus 2 equals to minus 2x plus 2. So bringing both the terms to the LHS side. So we get 2x plus y minus 2 and minus 2 equals to 0. So we get 2x plus y minus 4 equals to 0. I would like to tell you one important clue. Here are the two parallel lines and one was already given, 2x plus y plus 6 equals to 0, and we obtained the equation of required line that is also parallel to the given line, 2x plus y minus 4 equals to 0. What is your observation? Your observation is that the constant terms, here is a minus 4 and here is a 6. In both the equation, only constant terms are different, but the x coefficient, that is 2x, here also 2x, here is a y, here is a y. So in both equations, x and y terms are same. Only difference is in the constant term. So very important conclusion after doing this problem is that parallel lines differ only in constant terms, whereas the x and y terms are the same. Example 2, find equation of line passing through the point 1, 2 and perpendicular to the line 2x plus y plus 6 equals to 0. Solution. First of all, we draw the rough diagram here. Find the equation of the line passing through the point. So let us call this is the required line, and this line is passing through the point A1, 2, and it is perpendicular to the line. So it is another line, 2x plus y plus 6 equals to 0. So required line, this is the required line, and this is given line. Let us say the slope of the required line is m1 and slope of the given line with the m2. Both are perpendicular to each other. Now, slope of the given line, we compare it with standard equation ax plus by plus c equals to 0. So, m2, that is the slope of given line, is given by minus a upon b, where a equals to 2 and b equals to 1. Therefore, m2, that is the slope of given line, minus a upon b, that is minus 2 upon 1. Therefore, m2 value is minus 2. Now, since both the lines are perpendicular to each other, so we need to get the value of m1. So how to get the value of m1? That is product of slope. Whenever the two lines are perpendicular, the product of slope equals to minus 1. By using this relation, we can easily find out the slope of required line, m1. So m1 multiplied by m2, that is minus 2, equals to minus 1. Therefore, m1 equals to minus 1 divided by minus 2, that is equals to 1 upon 2. Therefore, m1, the value of m1 equals to, the value of m1 equals to 1 upon 2, and it is passing through the point A1, 2. So, equation of required line can be obtained by using one point slope form, that is y minus y1 equals to m1 multiplied by x minus x1. So y minus y1, this is x1 y1 nothing but the point through which the line is passing. So y minus y1, that is y minus 2, equals to m1, that is 1 upon 2, and x minus 1, simplifying 2 into y minus 2 equals to 1 multiplied by x minus 1. 2y minus 4 equals to x minus 1 implies x minus 2y minus 1 plus 4 equals to 0 implies x minus 2y plus 3 equals to 0. So the equation of required line, this is a required line, is given by x minus 2y plus 3 equals to 0. So this is the way we can find easily the equation of parallel lines and perpendicular lines. I hope after going through these two examples, now you can manage to find the equation of parallel lines and perpendicular lines. Meet you again with next topic, next video. Till then, wish you good luck. All the best.